a visitor from outside our solar system, behaving like nothing we have ever seen. On October 4, 2025, NASA's Perseverance rover on Mars captured an image of an object that defies all explanation. The image shows something structured, massive, and completely unexplainable. This wasn't a blurry photo of a distant comet, it was a clear anomaly that brought the scientific community to a silent halt. Within hours of its internal analysis, the official data streams went dark. What did Perseverance really capture? And what has NASA discovered that they are not yet ready to reveal? Let's explore this together.
The accidental photo.
It all began with a ghost in the Martian twilight. On Sol 1643 of its mission, the Perseverance rover performed a routine shutdown procedure. Its right-side navigation camera, NavCam Right B, an engineering camera designed purely for hazard avoidance, turned toward the horizon. The resulting image, timed at 1832 UTC, should have been unremarkable. Instead, hanging in the upper right corner was a faint blur, no brighter than magnitude 8.7, where no star should be. At NASA's Jet Propulsion Laboratory, Dr. Justin Maki, the lead imaging scientist for the mission, initially had his team flag it as a sensor artifact, but the blur persisted over 17 consecutive 1-megapixel frames, shifting just slightly against the background stars. Before the mission team could formally investigate, the image was uploaded to NASA's public archive. It was there that the discovery truly exploded. Amateur astronomers, using publicly available trajectory data, realized the blur's position perfectly matched the predicted path of interstellar object 3I Atlas. The signal-to-noise ratio was a mere 4.2, almost statistically invisible, yet undeniably real. A geology rover, by sheer chance, had just become the first observatory on another world to photograph a visitor from the stars.
Confirming the visitor.
How do you turn an anomaly into a fact? Once the internet started buzzing, the pressure was on for official confirmation. Engineers at JPL, under the guidance of orbital dynamics experts like Davide Farnocchia, began to reconstruct the rover's exact positioning. They cross-referenced every piece of data: the Mastcam Z's elevation, the Navcam's exposure angle, and the star tracker logs. Every single data point confirmed the impossible. The camera had been aimed at the precise segment of Martian sky where 3I Atlas was traveling. Its distance at that moment was calculated to be a mere 28 million kilometers from Mars. The faint drift of the object between the frames even matched its calculated motion, relative to the planet's rotation. The realization sent shockwaves through internal channels. Planetary scientists then called for checks from orbiters like the Mars Reconnaissance Orbiter and the Trace Gas Orbiter. Both registered a subtle optical fluctuation in the same quadrant of the sky. While not as clear as the rover's photo, it was enough to verify a presence moving at an interstellar velocity of nearly 200,000 miles per hour. The anomaly was now a confirmed target, shifting the mood at mission control from skepticism to a palpable sense of awe.
Reconstructing the image.
With confirmation in hand, the real work began. At the University of Hawaii, Dr. Karen Meech, a renowned expert who led the characterization of the first interstellar object Oumuamua, was brought in to consult. Her team took the 17 raw NavCam frames and began a painstaking reconstruction using a Lucy-Richardson deconvolution algorithm, a process designed to sharpen blurry images. They expected to see a slightly sharper smudge, but what emerged was stunning. The blur resolved into a distinct, elongated object with an angular size of nearly 50 pixels, translating to a physical length of at least 4 to 6 kilometers. But the shape wasn't the strangest part. An analysis of its light curve revealed a physical impossibility. As Dr. Meech explained, 3I Atlas produced an inverted phase curve with a positive slope of plus 0.03 magnitude per degree, meaning it grew brighter as the viewing angle increased. This phenomenon is unheard of in natural bodies, suggesting its surface wasn't just reflecting light, it was somehow gathering and redirecting it in a non-Lambertian way that defied the laws of passive reflection. It was as if parts of the surface were actively brightening in response to sunlight.
Light defies rules.
What if something from outside our solar system doesn't play by our rules of physics? The inverted light curve was just the beginning. The next step was to understand why the light from 3I Atlas behaved this way. Using polarization analysis from both Mars orbiters and Earth-based telescopes, astronomers began plotting the object's optical signature. This work, in the hands of a polarimetry expert like Dr. Ludmila Kolokolova, would reveal the impossible. Normally, light bouncing off cometary dust becomes positively polarized at larger viewing angles, but 3I Atlas showed an extreme and constant negative polarization, a reading never before seen in any celestial body. This implied the particles surrounding it were not fluffy ice grains, but dense, irregular metallic structures. The data even suggested the dust grains were like microscopic shards of crystalline glass or oxidized metal, scattering light in chaotic directions. When the results were independently verified, it was official. 3I Atlas displayed the strongest negative polarization ever recorded. Sunlight itself was behaving differently around this visitor, as if passing through a completely foreign medium, forcing scientists to confront the possibility that the object's composition was based on a chemistry unknown to us.
The backwards tail.
The mystery deepened when high-contrast images from the Mars Reconnaissance Orbiter revealed another impossible feature. Emerging from the sun-facing side of 3I Atlas was a faint, narrow streak of light extending over 80,000 kilometers. It wasn't a tail pointing away from the sun, but an anti-tail pointing directly toward it. Comet specialists like Dr. Geraint Jones from UCL's Mullard Space Science Laboratory have seen anti-tails before, but they are optical illusions caused by viewing geometry. This was no illusion. Its stunningly low width-to-length ratio of 1:15 persisted across multiple observations, confirming it as a real, physical structure. Spectral analysis showed it was composed of micron-sized silicate and oxidized metal grains with a density of 2.8 grams per cubic centimeter, far too heavy to be pushed by solar wind. This was a collimated beam of matter being actively ejected forward. To achieve this, simulations by Dr. Jones's team showed the nucleus had to be extraordinarily dense and cohesive. 3I Atlas wasn't a fragile snowball, it was a monolith projecting a beam of matter into the sun, a behavior with no known, natural precedent.
Solar blast.
What happens when an unstoppable force meets an immovable object? On October 6, 2025, just 2 days after the rover's image, the sun erupted. A massive coronal mass ejection, or CME, blasted from an active region and raced outward at nearly 2 million kilometers per hour. Solar physicists like Dr. Holly Gilbert at NASA tracked these events, and their models predicted the CME's front would cross the orbit of Mars exactly where 3I Atlas was traveling. This was a direct hit from one of the most powerful forces in the solar system. Across 3 observatories, tracking feeds flickered as brightness readings from the object spiked for 6 hours and then collapsed into absolute silence. Perseverance's own environmental sensors on Mars recorded a surge in electrostatic charge, a clear sign the shock front had arrived. When the CME passed, 3I Atlas was gone. No optical trace, no thermal signature, nothing. It was as if the sun itself had reached out and wiped the visitor from the sky. The initial consensus was grim. They believed they had just witnessed the complete disintegration of a unique celestial body.
The disappearance.
For 16 agonizing days, 3I Atlas was gone. Every scheduled search window from every major observatory came up empty. It was as if the CME had simply erased it from existence. The timing was too perfect to be a coincidence. Then, a single ghostly echo emerged. Buried in the logs from the European Space Agency's solar orbiter, Dr. Daniel Miller, the mission's project scientist, found a non-correlated event, a half-second pulse of polarized light moving opposite the CME's flow. The pulse had a distinct energy signature of 0.2 GeV, too powerful for a simple reflection and possessing a coherence that suggested an artificial origin. Its origin point aligned with the last known vector of 3I Atlas to within 0.2 degrees. This was the final, fleeting glimpse of the object as it was engulfed, suggesting it hadn't just been hit, it had responded. The photograph from Perseverance on Sol 1643 suddenly took on a new, solemn meaning. It wasn't just the first image of this visitor, it was the last image taken before the sun itself struck it down.
Impossible mass.
What does it take to withstand the full force of the sun and not even flinch? When orbital tracking finally resumed, the first surprise wasn't that 3I Atlas had survived, it was that its path had not changed at all. Even after being hit by a massive CME, its trajectory remained perfectly stable. Celestial mechanics experts like Dr. Renu Malhotra would confirm that there was no measurable drift, no sign of acceleration or deflection. This stability became the key to a new mystery. The brightness spike during the solar blast suggested jets of gas had been released, and the recoil from that alone should have nudged the object off course. The fact that it hadn't moved meant its mass was vastly greater than anyone imagined. New models from both NASA and the European Space Operations Center were run. To maintain that level of inertia, the object would have to weigh more than 33 billion tons, 1,000 times the mass of a typical comet. Its effective density was closer to solid iron. It was a true astronomical paradox, a body massive enough to ignore the sun, yet delicate enough to shed dust without recoil. This invalidated nearly every theory that described it as a natural comet.
Martian chemistry.
As analysts dug deeper, spectral data from the Trace Gas Orbiter delivered another shocking revelation. Faint but unmistakable signatures appeared in the light from its halo iron oxide, silicates, and perchlorates. At Caltech, Dr. Bethany Ehlmann, a leading expert on Martian mineralogy, initially assumed it was contamination from Mars's atmosphere. But ground-based telescopes soon reported the same pattern. The data showed a deep absorption band at 860 nanometers, the unmistakable spectral fingerprint of crystalline hematite. After calibration, the object's dust showed a 94% spectral match to the regolith of Jezero Crater, where Perseverance itself was driving. The conclusion was unavoidable. The chemistry didn't match an icy body from deep space, it matched the crust of a terrestrial planet. This reframed everything. 3I Atlas was a planetary fragment, a piece of a long-dead Mars-like world from another star system, expelled by some ancient cataclysm and carrying the exact same mineralogy as the world now observing it.
Geometric patterns.
Is there a difference between coincidence and choreography? Once the orbital reconstruction was complete, analysts noticed a pattern that defied probability. 3I Atlas wasn't entering our solar system from a random angle. Its inbound path was aligned with the ecliptic plane, the same thin disk where all the major planets orbit. No known interstellar object had ever done that. Furthermore, its route between August and October 2025 intersected the orbital paths of Mars, Venus, and Jupiter in a sequence of near-perfect harmonic intervals. The odds of this happening naturally were calculated at less than 1 in 10 million. Then came the most chilling discovery, tracing the object's vector backward, as a researcher like Seth Shostak at the SETI Institute might do, placed its origin astonishingly close to the source region of the 1977 WOW signal. The alignment wasn't perfect, but it was close enough to reignite old debates. It looked less like coincidence and more like a planned trajectory. The data felt uncomfortably ordered, moving the discussion from the realm of natural phenomena to a place few scientists were willing to go. In the weeks that followed these discoveries, the public data streams went quiet. Mission logs from Perseverance were marked data under review. No new coordinates for 3I Atlas were released. It wasn't an overt act of censorship, but something far more unnerving. Institutional silence in the face of data that did not fit any known model. The image from Sol 1643 is now known quietly as the frame that shouldn't exist. It is the last confirmed sighting of a visitor that defied physics, survived a solar blast, and followed a path that looked unnervingly intentional. What did Perseverance really capture on that lonely Martian evening? Let us know your thoughts in the comments down below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe's greatest mysteries. Thanks for watching Stellar Tech.